Hi everyone, in today's lesson we're going to talk about a finite geometric series, which is the sum of a geometric sequence. Here's the formula that we will use. The S sub n is the sum of the nth terms, n is the number of terms, a sub 1 is the first term, and r is the common ratio. So example number 1 says, determine the sum of the first 10 terms of this series. Notice how there's pluses and minuses in between them. They're giving it to you as a series rather than a sequence. The sequence would look like this: -2, 4, -8. Either way is fine. They would just call the comma one, this guy right here, the sequence. And they would ask you to find the sum. So I'm going to start by writing the formula. So we have S sub n is equal to a sub 1 minus a sub 1 times r to the n over 1 minus r. So it tells me that they want us to find the sum of the first 10 terms. That tells us that our n value is equal to 10. N is the number of terms. It looks clear that we have our first term, which is -2. So a sub 1 is -2. And it looks as though we also need our r value. So if you look at the sequence that I wrote out here, -2 to 4 to -8, what do I have to multiply 2 by to get -4? And then what same value do I multiply 4 by to get -8? So you should be recognizing that that r value is -2. Another way to do it is just divide. So 4 divided by -2 is -2. -8 divided by 4 is -2 as well. So let's go ahead and plug in what we know. We know we want to find the sum of the first 10 terms, so n is 10. A sub 1 is my first term, which is -2, minus -2 again for my a sub 1. My r is also -2. My n is 10, all over 1 minus -2. Wow, that's a lot of -2's. But the idea behind this is that if you plug this into the calculator using that alpha y equals button and all the parentheses, it's just a quick and easy plug into the calculator. When you do so, you should get 682. So take a minute, double check and see if you can get that number, and that'll be the sum of the first 10 terms. All right, let's try another example. Okay, number 2 says, find the sum of this sequence 2, 6, 18, ... all the way up to 120. There is a typo, and 120 is actually not the last term. So we'll just rewrite it completely. I want to find the sum of the sequence 2, 6, 18, ... all the way up to 1,458. So let's start with the formula. So we have S of n equals a1 minus a1 r to the n over 1 minus r. So it looks as though I have my first term. My first term is 2, so we'll call that a sub 1. And I can go ahead and put that into the formula here, 2 minus 2. And I'm just going to put parentheses and leave some spaces. R is my common ratio, so how do I go from 2 to 6 to 18? 2 times 3 is 6, 6 times 3 is 18, so in fact my R is 3. I can go ahead and put that in both of those spots. And the only thing I need is to find this n value, so I could put it here. So what we're going to have to do is use our formula that we learned last week. A sub n equals a sub 1 r to the n minus 1 power. So my a sub n is this guy. This is my last term. So I can go ahead and put 1,458 here. My a sub 1 is 2, and my common ratio is 3. So we're going to use this information to solve for n. Now, a lot of you probably want to multiply these, but unfortunately you can't because this 2 is attached to this 3. This 3 is attached to this exponent by multiplication. So we're actually going to divide the 2 out, and that is where we're going to start. And that gives us 729 is equal to 3 to the n minus 1. Now you can solve this using common bases, or you can log both sides. I think logging both sides may be easier. So we're going to log the 729, and we're going to log the 3 to the n minus 1. And we're not going to forget that we take a power and we drop it like it's hot. So n minus 1 times log of 3 and keep the log of 729 on the other side. To isolate the n, we're going to divide by log of 3. So why don't you go ahead and type that into the calculator. So log of 729 divided by log of 3. You should be getting 6. And then just add 1 to both sides, and you get n is equal to 7. Now, if this way is a little bit too confusing for you and you don't like all of this work, you absolutely can just do testing it out. So in your calculator, do 2 times 3 is 6, 6 times 3 is 18. Keep multiplying by 3 until you get 1,458, and then just count the number of terms. You should get 7. So if you wanted to, you really could, and I'll show you down here. So you've got 2, 6, 18. So take 18 and multiply it by 3. You get 54. Multiply that by 3, 162. Keep going. Times 3 is 486. Times 3 is 1,458. So 1, 2, 3, 4, 5, 6, 7 terms. So you can do it that way without having to do logs. Yes, it's a little bit longer, but it'll always still work. So now that we know that n is 7, we can go ahead and put 7 here, and I want to find the sum of 7 terms. So go ahead, type this into the calculator. Suggestion is to use alpha y equals, and then hit resume when you're ready for the answer. All right, I got 2,186. So that is the sum of these 7 terms. All right, let's try another example. Okay, so the question is asking how many terms. So when I ask how many terms, that's asking for n. In a geometric series, if the first term is 4, so that's a sub 1, and the common ratio is 3, that's the r value, and the sum of the series is 160, that is your s sub n. So let's start with the formula. So I have s sub n is equal to a1 minus a1 times r to the n over 1 minus r. So let's go ahead and plug in what we know. Well, we know the s sub n is 160. The first term is 4. The common ratio is 3. And the r common ratio again is 3. So the goal is to solve this equation. So let's use some algebra. So we know that this 160 will stay the same. And this we can do 4 minus 4 times 3 to the n. Unfortunately, we can't multiply these because of PEMDAS, right? This 3 is attached to that n. Divided by 1 minus 3, which is negative 2. So we can put this over 1 and we can cross multiply. So 160 times 2, negative 2, is negative 320 equals 4 minus 4 times 3 to the n. So again, you cannot multiply these. The goal is going to be to isolate this 3 to the n. So let's do that. Let's minus the 4 on both sides first. So I get negative 324 equals negative 4 times 3 to the n. So again, to isolate this 3 to the n, we have to divide out that negative 4. So take in the calculator 324 and divide it by 4. I'm just going to follow it up here. You should get 81 equals 3 to the n. Now you can log both sides or you can use common bases. So logging both sides will work. So log of 81 equals log of 3 to the n. Drop it like it's hot. N times log of 3. So log of 81. Divide both sides by log of 3. And you should get your n value. So go ahead, type that into the calculator, and then hit resume when you're ready for the answer. Okay, so I got n is equal to 4. So 4 terms in this sequence. All right, that's it for today. If you have any questions, please let us know. Have a good one.